Right, so this is the 6E handout, and we'll go through the notes for this. Okay. So far we've learned about AA similarity. So that means that if you can show that two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. And then once you have that, you can either figure out, you can set up the sides in a proportion, or you can say that the angles are all congruent to each other. So number one, first we want to figure out which triangles are similar. And there are three triangles in the picture. There's the big one, ABC, so I'll draw that over here. So here's the big one with the right angle at the top, A, B, C. And then that's cut into two smaller triangles. So here's one of them. And this one is A, D, B right there. And then there's another one that if you kind of shove those two triangles together, you form the big one. And this one is a B on top, a D right there, and a C over here. And right now I know that I'm telling you that all three of them are similar to each other. But the issue is, how do you get the letters in the right order? So one of the things that we can do is, well, I know this angle A right here is exactly the same as that angle A right there. Those are reflexive. They're the same one. And this angle C over here is exactly the same as that angle C over there. So I can do one other thing. Notice this triangle, the triangle on top and the triangle on the left down here, they have a right angle and a one curve in common. Right angle and one curve. So the third angles also have to match up, which means that this angle up here would have to have two curves on it, because that's what's left over here. Okay? In the second triangle, if I compare that to the top one, I already have a right angle and two curves. So up here, right angle and two curves. So two angles of this triangle are already the same as two angles of that triangle, so the third angles have to match up, which means that the missing angle up here has to have one curve on it. Okay, so now I can use that info to match up which triangle, or to match up the letters in the right order. So if I call the top triangle ABC, then the triangle down here on the left, ABC goes one curve to the right angle to the two curves. So in the bottom left triangle down here, it would have to go one curve to right angle to two curves. So that's going to be triangle ADB. And then if I do the same pattern for the third triangle, it would have to go one curve, right angle, two curves. So that's going to be triangle BDC right there. Okay. Now this type of diagram where you have a big right triangle chopped into two smaller right triangles, that's going to come up a lot over the next couple units, just so you know. Okay, we got to solve for x and y. So let's label up some of our diagram stuff here. So let's see. This side is 20. This one is x. AC is 16 plus y there. And then down on the bottom we've got AB is 20 again. The height DB is 12. AD is 16. This one's still 12. X here and y here. Okay, so let's try solving for x. So if we look at x, let's match up some sides here. X, right there, is the side between the one curve and the two curves. So in this triangle, that's going to match up with the 20. And in the top triangle, that's going to match up with the 16 plus y, right here. Okay. If we look at the, let's say, the 20 on the top, up here. Well, that's between the one curve and the right angle. So the 20 on top is going to match up with the 16 down here and the 12 in the triangle over here on the right. So let's match up some stuff. Now, I'm going to want to use this triangle on the bottom left because they're all numbers, so that'll come in probably the handiest. And so if I match up, let's see, I want to get x involved, and x is green in the triangle on the right. So if I match up left to right, I've got the 20 on the left over here is the green side, matches up with the x the same way that, I don't know, let's see. If I go with the gray ones, then I get two numbers, the same way that the 16 goes with the gray 12. We can simplify the 16 over 12, so let's do that so the numbers are a little bit easier. 4 over 3. And then if I wanted to cross multiply, I'll get 60 equals 4x, so x equals 15. So there's x. X is 15. Okay, and you can solve for y a couple different ways. One thing you could do, since this is a right angle over here, this one's a right angle too, so you could actually just do Pythag, 12 squared plus y squared equals 15 squared. But let's practice using the similar proportional stuff. So down here, if I look at the y is in black, and so that goes with the 12 over here. So if I go, let's use the gray ones again. 16 goes with 12. Oh, can it stop writing? Okay, sorry if the screen got shifted there. Something stopped working. So we were matching up the grays. So 16 goes with 12. The same way, so the grays go together, the same way that the black sides go together, so I get the y involved. So the 12 from the triangle on the left goes with the y. 12 over y. So if I reduce this again before we actually cross multiply, just to make the numbers easier, then I get 4y equals 36, so y equals 9. All right, so there's those two. All right, let's take a look at this one. So in this problem, it's going to be a proof, and you know we're going to use similar triangles because that's what this main idea is. And then there are three triangles in this picture. There's the BDC, so I'll draw that one by itself. So BDC, here's angle 1 right there. And then I've got the one that's kind of next to BDC, which is BCA right here, and there's angle 2. And then I've got both triangles put together, looks kind of like this, DBA right there, and there's an angle 1 right there. Okay, so let's see, we know angle 1 is congruent to angle 2, that's given. And so right away we've got a pair of angles matched up, so let's mark them in the picture. Angle 1 goes with angle 2, and then there's angle 1 again. By the way, I drew all three. I don't know which two I'm going to use yet, so because you're going to try and figure out which two triangles are similar. So that's what we've got so far. So then the next goal is to figure out, well, is there any other angles that I can match up for sure? And the ones that you can definitely match up is angle A with itself, because here's an angle A right here, and here's an angle A right there, and they're the same exact angle in the original picture. So in this step here, step 2, I'm going to say angle A is congruent to itself. That's reflexive. And now I've got a second pair of angles matched up. Okay, so we're up to there. All right, now if you look at that, I can't prove all three triangles are similar, but I can prove that these two triangles are similar because I have AA. So I'm actually going to erase this guy for now. That guy's not going to come in handy for this proof. So we're going to use those two triangles. So if I call, let's say the one that's smaller, if I call that triangle ABC, then that's going to be similar to triangles. So ABC goes 2 curves, 1 curve, no curve. So I'd have to go ADB. And the reason is, well, I matched up 2 pairs of angles. Alright. So now I'm going to use either CSSTP, corresponding sides of similar triangles are in proportion, or CASTC, corresponding angles of similar triangles are congruent. Now if you look at what you're trying to prove, they deal with sides. So I'm probably going to use the one over here that deals with sides. Corresponding, I'll write it out just so you see it. Corresponding sides of similar triangles are in proportion. So let me get rid of that. Oh, lost the O-N. Okay. So now the key is, well, what do we need to match up? So let's take a look. All right, I know that I've got to involve a couple of ABs somehow. So let's look at the AB in the first triangle. And if you look at the AB up here, that's between the two curves and the one curve, so that's got to go with the AD in the bigger triangle. And if I look at, let's see, so I've got one of the ABs and the AD covered. Let's look at AC. So AC is right here. That's between the no curves and the two curves. So that's going to go with this guy right here, AB, between this one, which is between the no curve and the two curves. So if I set up a proportion, I could go blue, little blue over big blue. So I'll write that down. AB over AD equals little green over big green, AC over AB. Yep, that's right. And my reason is CSSTP, right? That's the reason. And then if I cross multiply, AB times AB is AB squared. And then I've got AD times AC, which we get from cross multiplication. And that's what we're trying to prove, so we're good. Okay, let's move on. So this next chunk here is a lot of text. Really what it's saying is the other two ways of proving two triangles are similar to each other. So we got AA, but it turns out you can also do SSS and SAS similarity. So the way that the way you match up sides is you set up proportions. So here, I'll make up an example. I'll just you don't have to write this down, but I'll just kind of tack this on down here at the bottom. So let's say I have a triangle that looks like this. Let's say this is like 7, 10, and 15. And then I've got another triangle here. In fact, let me make it less obvious how this should look. So let's say here's another triangle. This one is let's say 45, 30, and 20. Okay, so one of the ways you can check if they're similar is by seeing, can you match up two angles, but I don't know anything about the angles. So instead, you can match up sides. Now in this one, the 7, if I'm trying to match up these sides, the 7 is going to have to be paired up with the 20 because the short side on the triangle on the left is going to match the short side on the triangle on the right. So I'm going to be comparing 7 with 20 and then seeing if that's the same as, and then you match up the medium sides. So in this case it'd be the 10 goes with the 30 because those are the medium sides. So is that the same as 10 over 30? And then you check, is that the same as the long sides matched up too, right? So, whoop. So we're checking, is the 15, does that compare to the 45 in the same way? So 15 over 45. And if you reduce them, well, 7 over 20 doesn't reduce. This is 1/3 and this is 1/3. But that's not the same. 7 over 20. So it turns out that this is not enough to say that the triangles are similar. In fact, you can say they're not similar because this pair of sides is not in proportion. But let's say it was. Let me change this. So it's 21. Okay. Now if you redo this problem, you've got a 21 down here instead, and this thing also turns into 1/3. By the way, you can use a calculator if you want to just get decimals, especially if they're terrible looking numbers. So the 7 over the 21 compares to the 10 over the 30, compares to the 15 over the 45, all the same way. So you can say, yes, the triangles are similar because of, and notice you didn't just pair up one pair of sides. Here's a pair of sides, here's a pair of sides, here's a pair of sides. You've already paired up all three pairs of sides at once. So you'd say, yes, the triangles are similar because of SSS similarity. Okay? Now let me tweak this a little bit. Let's say you didn't know the third sides. But you did know that this angle right here was like 80 degrees, and this one was also 80 degrees. Well, then what you can do instead is you can pair up the sides that you know. So in this case, the shorter side is 7 connected to the 80, and that's going to go with the 21 connected to the 80 because that's the shorter side in the triangle on the right. And then we're checking, is 7 over 21 the same as the longer sides connected to the 80, 10 over 30. And yeah, we already know that's 1/3 is the same as 1/3. So this gives me a pair of sides matched up, two S's, right? But I also know that the angle in between them is the same. So I have two S's, and I have an angle in between them. So now I can say, yes, the triangles are similar because of SAS similarity. So we now can either check all three ratios, see if they're the same, and if they are, we got SSS similarity, or you can check two pairs of sides, see if the ratios are the same, and if the angle in between them is the same, then you can say SAS. And just so you know, SSS, SAS, AA, those are the only three reasons we're going to use for similar triangles. There's no like other hidden ones that I'm going to throw at you later on. So this is what we've got. So let's go back up here to number 3 and figure out, are these triangles similar or not? So in the first one, we've got a right angle already matched up. So I already have 1A matched up. And then I know that the 6, when I match this up, is going to have to go with the 12, not the 14. Partly because it just looks like it should, but also the 6 is the shorter of 6 and 7. So it's got to go with the shorter one of the 12 and 14. So it's got to go with the 12. And then we're going to pair up the 7 with the 14. And then we'll check those ratios. So is 6 over 12 the same as 7 over 14? And yeah, it is. They're both 1/2. So right away, we get a pair of sides matched up. Two pairs of sides matched up, sorry. And the angle in between them is the same, so we can say that the triangles have to be similar, and if I call the first one ABC, then the second one has to be EFD because of SAS similarity. Okay. Let's look at B. So in B, if I pick the 3 over here, I'm going to have to match it up. 3 is the shortest of 3, 6, 8. So I got to match it up with the shortest one of 9, 18, 24. And then if I match up the medium sides, it's going to be 6 goes with 18 over here. Oop. And then the long sides will get matched up. 8 has to go with 24. So if I check those ratios, little red over big red, check to see is that the same as little blue over big blue, check to see if that's the same as little green over big green. And yeah, they all simplify to 1/3, or if you use the calculator, 0.3 repeating. So we can say, if I call the first triangle IHG, then that started at I, went along the red, then the blue. So that would be the same as JKL, goes along the red, then the blue. So similar to triangle JKL because of, and in this case, I've checked all 3 pairs of sides and shown that they all have the same ratio there. Okay. If we look at the next one in C, well, we know that the vertical angle's got to be 40. And if you solve for the missing angle up on top here, you get 80. And then down here, if you solve for this missing angle, you get 60. So all 3 angles match up. So you have AA similarity. So if I call the first triangle, let's say NMO, then I went 60, 80, 40. So the other one, what letter is that? Let's say that's a Q there. So then the second one would have to be, let's see, what did I do? 60, 80, 40, so QPO because of AA similarity. Now the last one, if you want to check it, you can. You can check, does the 3 go with 5 the same way that 4 goes with 6 and 2/3? And it does. But there's no reason to check it. Because even if these guys do match up, the problem is that you have side-side angle, SSA. Well, that's not AA. It's not SSS and it's not SAS. So this one, maybe they are similar, but we don't have enough info. Okay. All right. Let's see how we're doing on time. All right, so let's take a look down here. Let's see here. We got two triangles, ABC and TRI. AB is 6, BC is 8, AC is 10, TR is 24, RI is 40, TI is 32. Okay, so the question is, are they similar? All we have are sides, so if they're similar, it's going to be because of SSS similarity. So let's match up the sides. I'm not even going to bother drawing this. AB is the shortest side in triangle ABC. So that's going to have to go with TR because that's the shortest of 24, 40, and 32. If I look at BC here, BC is 8. That's the middle side. TI is the middle side over here, 32. And then the longest side here is 10. So that's gonna have to go with the longest side over here, 40. So then the question is, are those ratios going to be the same? So if I take the shorter red side over the longer red side, is that the same as the shorter blue side over the longer blue side? And is that the same as the shorter green side over the longer green side? And if you simplify all of these, you either get 1/4, or if you use a calculator, 0.25 for all of them. So yes, the triangles are similar because of Sss similarity. Oh, and then maybe a diagram would help because it'll help us figure out which order to put the letters in. So if I draw this real quick, let's do, here's A, B, no, let's see, let's put A here and C here because AC is the longest side. Oh, it doesn't really matter, we're just kind of drawing it. So let's see, A, B, C, let's see, this one's going to be 6, 8, 10, so it's not really drawn to scale, but that's okay. And AB was red, BC was blue, and AC was green. And then in the other triangle, we've got T, I don't know, RI is the longest one, so let's do this. R goes here, I goes there, T goes here. TR is the shortest side, so that's the red. RI is the longest side, that was green. TI was the medium side, that was blue. So and in fact I happen to draw it so that they already match up. So if I call one of them ABC, that goes red, then green, then blue. So it's going to go RTI because of SSS. Okay, and then we got one last proof here to try. So let me redo that. I'm going to shrink this down so it's not in the way. Okay. So here's number 5. We got, let's see, they already pair up some sides here. AX goes with XC the same way that BX goes with XD. Okay, so we'll start with that given. AX goes with XC the same way that BX goes with XD, given. Okay, well, the nice thing about this is that's already one pair of sides and a second pair of sides matched up. And if you look at the picture, you can also pair up these vertical angles in the middle. So if I say angle AXB is congruent to angle CXD because vertical angles are congruent, well, now I've got the angle in between them matched up too. So now I've got SAS similarity. So if I call the first triangle AXB, the second triangle, remember I'm using similar here. The second triangle, I went AXB, that's red then blue. So it's going to be CXD. And now I'm using the reason side angle side similarity. Okay. So the goal is to prove AB is parallel to CD for whatever reason here. Well, the ways to get parallel lines are by using various congruent or supplementary angles. And if you notice here, I could now say this angle matches up with that angle. A goes with C. Angle A is congruent to angle C. Notice A is the first letter here, C is the first letter there. That's because we've already proven the triangles are similar, so way back up at the top of the first page, then we can use these two things. So I'm going to match up angles in this case, because that'll help me get parallel lines. So A is congruent to C because corresponding angles of similar triangles are congruent. And if you notice, A and C are alternate interior angles. So step 5 here could be, well then AB is parallel to CD because alternate interior angles that are congruent give me parallel lines. You also could have done it with B and D instead of A and C. Doesn't really matter either way. Okay, I hope that helps a little bit.